The next three problems, we're going to use some formulas from the formula sheet. And the ones we're going to use are called the sum or difference of two angles. You can see either add or subtract two angles together and take the cosine, and here's your formula, or adding or subtracting two angles and the sine and also the tangent. Now, one use of these formulas is a problem like number 61 here. You notice it says to find the exact value of the expression. I underlined it because the exact value normally means it's a special angle. But I go to my unit circle and I don't see 105 degrees in here. So the question is, how do we go about finding the exact value of this? Well, what you do is, one of the things you can do, if I'm looking for the exact 105 degree angle, I can take two other special angles and either add them together or subtract them, and if they equal 105 degrees, then I can go about and use my sum or difference formulas. For example, what jumps out at me is that 45 degrees plus 60 degrees, where everything's a special angle, you add those together, you get 105. So in a sense, this is what we can do to sort of get around this problem. Cosine of 105 is the same thing as the cosine of 60 degrees plus 45 degrees. And now I'm going to go look, and here's a formula when you're adding two angles together and taking the cosine. It's like cosine u, cosine v minus sine u, sine v. So this is really going to be cosine 60 degrees times a cosine of 45 degrees. And then I'm going to subtract the sine of 60 degrees times the sine of 45 degrees. Now these are all special angles, so I can go unit circle and figure things out. Cosine of 60, it's 1/2. Cosine of 45 is square root of 2 over 2. Minus sine of 60, square root of 3 over 2. Sine of 45 is square root of 2 over 2. Square root of 2 over 4 minus, so square root of 3 times square root of 2 is square root of 6. So when you're finally done, I can combine these into one fraction. Square root of 2 minus square root of 6 all over 4. That's the exact value answer of cosine of 105. How about the next one? All right, here's one in radians. It's a little trickier. The sine of 5 pi over 12. It's a little trickier because remember we're doing degrees and angles. We could just look here and quickly eyeball these and maybe find a couple. But here, since they're all fractions and they don't have the same denominator, we can't quite as easily figure it out. So what I think I might do is maybe I'll take these three initial angles, convert them to a denominator of 12, and then see what happens. In other words, pi over 6 becomes 2 pi over 12. So you multiply top and bottom by 2. Pi over 4, multiply top and bottom by 3, becomes 3 pi over 12. And then pi over 3, multiply both top and bottom by 4, becomes 4 pi over 12. Now, is there some combination of these that equal 5 pi over 12? Well, about 2 pi over 12 plus 3 pi over 12. That's 5 pi over 12. So really what we have is the sine of 5 pi over 12 actually equals the sine of pi over 6 plus pi over 4. Because pi over 6 is 2 pi over 12, pi over 4 is 3 pi over 12. Now I can go use the formula, the sine of adding two angles together. So it's sine cosine. Sine of pi over 6 times cosine of pi over 4. Plus cosine sine. So cosine pi over 6 times the sine pi over 4. Now these are all special angles. Let's see what they equal and try to simplify this thing. Sine of pi over 6 is 1/2. Cosine of pi over 4 is square root of 2 over 2. Cosine of pi over 6 is square root of 3 over 2. Sine of pi over 4 is square root of 2 over 2. So I'm going to have square root of 2 plus square root of 6 over 4. And that's correct. All right, I think there's one more on here we can do. And this one is sine of 19 pi over 12. Now, if like the one I just did, and tried to add them together, this is like 7 pi over 12. So I need to get some bigger values for my unit circle. How about, maybe we'll start, so the goal is the sine of 19 pi over 12. So let's just start looking. So pi over 3, the denominator 12 is 4 pi over 12. How about 2 pi over 3? Multiply top and bottom by 4, 8 pi over 12. If you add those together, you get 12 pi over 12, which is not what we want. How about 3 pi over 4? That's like 9 pi over 12. No combination yet. How about 5 pi over 6? Multiply by 2 to get 10 pi over 12. Aha! Look at this. 10 pi over 12 plus 9 pi over 12. There we go. So it looks like now the sine of 19 pi over 12 can also be rewritten as a sine of 3 pi over 4 plus 5 pi over 6. Now if I go use my formula sheet, once again this is the sum of adding two angles together. Sine cosine and then it's plus cosine sine. So let's These are all special angles. Let's go. I think I messed up here. Wow. Sine 3/4 cosine 5/6 should be cosine. Wow. I wrote the same thing twice. So sine of 3 pi over 4 is square root of 2 over 2. Cosine of 5 pi over 6, negative square root of 3 over 2. Cosine of 3 pi over 4, square root of 2 over 2. The sine of 5 pi over 6, simply 1/2. So this is negative 4. You multiply these together, negative 6. Negative square root of 6 over 4 plus square root of 2 over 4 square root of 2 minus square root of 6 over 4. Looks like I messed up on a sign. Oh yeah, right here, cosine 3 pi over 4, sorry. Both those are negative. Okay, so that's one use of those sum of difference formulas to help us find special values of angles.